Pre-statistics. Linear functions part 3. We'll begin with lesson objective number 2. Model a real-life situation using a linear function. Example 5. Biologists have found that the number of chirps some crickets make per minute is related to temperature. The relationship is very close to being linear. When the crickets chirp 124 times a minute, it is about 68 degrees Fahrenheit. When they chirp 172 times a minute, it is about 80 degrees Fahrenheit. A. Find an equation for the line that models this situation. B. If the temperature is 90 degrees Fahrenheit, predict the number of chirps per minute. C. How warm is it when the crickets are chirping 150 times a minute? Solution. We first want to identify the independent and dependent variable. The number of chirp depends upon the temperature, so temperature is the independent variable, which we'll call T, and the number of chirps, C, is the dependent variable. So we are given 2 points, 68, 124, and 80, 172. So from our last two videos, we're given 2 points. We want to find the equation of a line that contains those 2 points. We can do this algebraically, or we can use the graphing calculator and use the linear regression command to find the line between these 2 points. So to find the line containing the 2 points using the calculator, I'll go to Stat, number 1 for Edit. I've got my X coordinates in list 1. I've got my Y coordinates in list 2. I'll go to Stat, Calculate, number 4 for linear regression, and then finally calculate. So the equation is y equals 4 times x minus 148. Now, putting this equation in the terms of this problem using the variables c and t, we have c equals 4 times t minus 148. So that's the answer to part A. Part B, we want to know how many chirps happen when the temperature is 90. So in this case, we know t is 90 and we're finding c. So substituting 90 in for t, we have 4 times 90 minus 148 equals c. 4 times 90 is 360. Subtract 148, we get 212. So according to the model, when the temperature is 90 degrees, the number of chirps 212 per minute. Part C. For part C, we want to find the temperature when the number of chirps is 150. So substituting 150 for C, our equation becomes 150 equals 4t minus 148. Solving for t, we need to add 148 to both sides of the equal sign. We have 298 equals 4t, and dividing by 4, we get 74.5. So, according to the model, when the number of chirps is 150 per minute, the predicted temperature is 74.5 degrees Fahrenheit. Let's do another example. Example 6. All tickets for a concert are the same price. The ticket agency adds a fixed fee to every order. A person who orders 5 tickets pays $162.85. A person who orders 3 tickets pays $102.89. A. Find the equation relating the total cost to the number of tickets purchased. B. How much do 10 tickets cost? Our first step is to identify the independent and dependent variables. The total cost depends upon the number of tickets sold. So cost is the dependent variable. It depends upon the number of tickets sold. So for this example, I'm using C for the dependent variable and N, number of tickets sold, as the independent. So if we were to write this as an order pair, it would be N comma C. N is the independent, C is the dependent. We are given 2 points. 5 tickets cost $162.85. There's our first point. And our second point, 3 tickets cost $102.89. So we find the equation of the line that contains these 2 points. You should get C equals 29.98 times N plus 12.95. $12.95 is the constant fee, and $29.98 is the cost of each ticket. So the slope, as the number of tickets increases by 1, the cost increases by $29.98. And this is the value of B, so when the number of tickets is 0, there still is a $12.95 charge. Part B, we want to know how much would it cost to order 10 tickets. In this case, N is 10. We substitute that in. So we have 29.98 times 10 plus $12.95. And the answer would be $312.75. Thanks for watching.